Welcome back to this lecture on functions. In this third segment, we're going to review the graph of a function. So the definition of a graph of a function is a two-dimensional drawing or representation of the ordered pairs that make up the function. Remember that a function can be defined as a special kind of relation, and a relation is a set of pairs where the first element is an element of the domain, the second element is an element of the codomain. So let's take a concrete example of a function from the set of integers to the set of integers. So the domain and codomain are the same. And the function is defined as f of n, that is the image of n by the function f, is the integer 2 times n plus 1. So to draw the graph of this function, let's assume we have some graph paper, and we're going to draw a horizontal line that is called the x-axis with an arrow to the right to indicate that the values of the domain are going to grow or increase in value from left to right. So the further to the right, the larger the integer in the domain. We're going to indicate the specific location of each integer by a tick on the x-axis. And similarly now we're going to consider the vertical dimension by drawing the y-axis that points up. So that means as you go up in the graph, the integers increase, and these integers represent the values in the codomain. Again, we're going to indicate each distinct integer in the codomain with a tick on the y-axis. And the intersection of the two axes is the point 0, 0. That is, this is the point where n is equal to 0 in the domain, and this is also 0 in the codomain. So when you move this way, the integers increase positively. When you move this way, the integers decrease toward the negative integers. And similarly, on the y-axis, you got 0 here, 1, 2, 3, 4, 5, and going down, 0, minus 1, minus 2, minus 3, minus 4, and minus 5. Now, we have a two-dimensional canvas on which we can represent the function f, and we're going to represent each pair in the function as a black dot. So let's start with the easiest pair to compute. If n equals 0, then the image of 0 by f is 2 times 0 plus 1, or 1. So the pair 0, 1 is the first pair to draw on this graph, and it's represented here by this black dot. And this black dot is positioned right here because starting at the origin here, if you move 0 horizontally from the origin, that means you don't move. And if you move 1 from the origin in the y dimension, you reach this point. And therefore, the pair 0, 1 is drawn at this position. Now, let's increase the value in the domain. Let's take the next integer up, which is 1. F of 1 is 2 times 1 plus 1, or 3. So the next pair to draw is the pair 1, 3. Starting at the origin, you move to the right 1 tick, and then you move up 3 ticks for the pair 1, 3, and so you add the point right there. Next, let's consider the next pair for n equals 2. 2 times 2 plus 1 is 5, so we need to draw the pair 2, 5. That's 2. That's 5 up here. That's the next pair. Notice if I went to the next larger value for n of 3, then f of 3 would be 3 times 2 plus 1. That would be 7. That would be out of the canvas. So let's stop here for the positive values of n. Now we're not done, since we still need to go down to the negative values of n. Remember that the domain is the set of all the integers, including the negative ones. So starting from 0 going to the left, we get minus 1. 2 times minus 1 plus 1 is minus 2, plus 1 is minus 1, and minus 1 is 1 down vertically. So the next point in the graph of the function is here. And so on and so forth. I'll let you finish the graph. So what you notice is the points are aligned in a straight line. That's not surprising, since you probably remember that this is the equation of a line where the slope is 2 and the y-intercept is 1, meaning the line intersects the y-axis at the value 1 for y, which is right here. However, this graph is not a line because the domain of the function is the set of integers, not the set of real numbers. So we don't have a value here or a point anywhere between 0 and 1 because that's not even in the domain of the function. So that's why instead of drawing a line, we have to draw discrete points where the integers are, because the domain of the function is the integers. Now let's consider a second example of a function. This function is related but different from the previous one. Let's call it f again. And notice its definition is the same as the previous one. We just changed the n to an x. But really it's not the same function because it has a different domain and a different codomain. In this case, it's the set of real numbers. And by the way, that's the reason why we changed the name of the variable here. We typically use the letter n for an integer and the letter x for a real number. But again, these are dummy variable names, so the name of the variable really does not matter. So the point is, this is a related function, but it's a different function since it doesn't even have the same domain and codomain. So let's draw the graph of this function. So here we go with the basic setup with the two axes. Now, one thing we already know is that when x is an integer, then the image of x by f is going to be the same image as we had for this function, because the definition of the image is the same, 2 times the input plus 1. So basically, the way you would draw this function is if you would first realize that this is the equation of a line, then you would compute two particular points on that line, say for x equals 0 and x equals 1. You would end up with those 2 points, here and here, and then you could take a straight edge or ruler and just draw a line through those 2 points. And so the graph of this function is this straight line. And it's obvious now that this function is different from that one. They have a completely different graph. This is a straight line, whereas this graph here is just a set of discrete points. So whenever you are studying a function, don't focus only on the definition or the formula for the function, for the image of the function. Make sure you take into account the domain and codomain of the function as well. Now let's quickly consider a couple more examples of graphs. Consider the function from the set of integers to the set of integers defined by f of n equals n. This function is called the identity function because the image of every element in the domain is itself. So the graph of this function is going to be represented by a set of dots, since the domain is discrete here. It's not the real numbers, but the integers. And every pair is going to look like x comma x, or rather n comma n. So f of 0 is 0, so we have the pair 0, 0 on the graph. F of 1 is 1, so the pair 1, 1 is on the graph. Then 2, 2, and so on and so forth. And don't forget, of course, to draw the second half of the graph on the left-hand side for the negative integers. F of minus 1 is minus 1, f of minus 2 is minus 2, etc., etc. And this is the graph for the identity function, where the domain is the set of integers. Now, a different function is the identity function, So it has the same formula here, but it's defined on the real number, on the real numbers. Then in that case, the graph of that function would be just a straight line going through all of these points. Now finally, let's consider this fourth function, also defined on the integers by the expression f of n equals n squared. So this one is definitely not the equation of a line, since it has a square power in its definition. I'm sure you've seen that function before, so let's draw it. Notice in this case I have drawn the x-axis all the way at the bottom of the graph. That's because I know that n squared, here the image of every element in the domain, is never going to be negative, since n squared is never negative. And therefore I don't need this half, the bottom half of the graph. So what I did is I simply shifted the x-axis downward, so now I have more room above the x-axis. So let's start with the easiest point of all. As usual, for n equals 0, 0 squared is 0, so the point 0, 0 again is in the function. For n equals 1, well, 1 squared is again equal to 1, so this function starts out looking like the identity function. But of course, when you move up to n equals 2, 2 squared is 4, so the next dot to draw in the graph is the pair 2, 4. Remember, 1, 2, 1, 2, 3, 4. And here it is. The next integer up is 3. 3 squared is 9, so we draw the pair 3, 9. And I'm going to stop here on the right, since the next point is going to be off the graph here on the top. Don't forget to draw the second half on the left of the y-axis. And if n is equal to minus 1, the minus 1 squared is 1. So the next point is minus 1, 1 right here. Minus 2 squared is 4. So the next point is right here. And so on and so forth. Minus 3 squared is 9. And so this is the discrete version of what you know as a parabola. So if the domain of the function here was the real numbers, then this would be this graph would be the graph of a parabola, where you would have to draw a continuous line going through these points. Here we just have a discrete version of it. So this concludes our segment on graphs of functions.